An armored van must travel from D, make a pickup at J, stop at W, and finally go to B. And you can look at the street map below to see what they mean. The question is, how many direct routes are there from D to I? So you want to start at D and you want to end at I. Well, obviously that doesn't even concern some of the map. So as I'm looking at this problem, I want to realize that I'm only looking at that segment of the road map. So if you can focus in on the important part, and if you can look far enough ahead, you're probably going to see that this is one of the subtasks that's going to end up allowing us to apply the fundamental accounting principle. But anyway, right now we're just looking at how many direct routes there are going from D to I. Direct route means without taking more time or more distance than you need to. A direct route would be getting there as quickly as you can. And one thing I would notice originally when you first start out is that no matter how you look at it, you're going to end up having to go down 4 blocks and to the right 4 blocks. Now there are bunches of different orders you can do that in. You can go down 4, then right 2, or you could go right, down, down, down. Anyway, some combination. So the number of direct routes are really, if you think of D as being down and R being right, all you have to do to solve this problem is figure out how many combinations of D's and of 4 D's and 2 R's there are. And we've been doing that with tree diagrams, so let's just do that here. The main thing is to be patient and take your time. So I'm going to start off with a tree diagram by noting that from D I can either go right or down. So that's my first choice. Keep in mind at all steps in this you've got to have 4 D's and 2 R's in every branch. Okay, I can either go down or right to start with. Now suppose I went down. Well, I've got to have 4 downs and 2 rights, so I can go either way again. I can go down again or I can go to the right. Continuing this logic, suppose I go down and then down. Well, I still have 2 more downs to go and 2 more rights to go, so I can still either go down again or to the right. Continuing, what if I go down, down, and down? Well, I still have 1 more down that I can use, and I have 2 rights that I can use, so I can either go down again or to the right. Now I'm getting to where I've got to think about this, because if I go down, 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 I've already used all 4 of my downs. So I don't have any more downs. That means I've got to use the next 2 for my rights. So once you figure out you've used all 4 of your downs, you just go straight across doing right and right. And just keep doing this. Suppose I go down, 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 right. Well, now I've only used 3 downs and 1 right, so I can use another down or I can go right. I can go either way. But suppose I go down, 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 right, down. Well, now I've used all 4 of my downs. I don't have any choice but to go right on the last one. If I go down, 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 right, right, now I still have a down left, but I've used both my rights, so I have to go down the last time. It takes a while to do this, but it's not difficult. Now suppose I go down, down, and then right. Well, I still have 2 more downs and 1 more right, so I can go either way, down or right. If I go down, down, right, down, I've still got 1 down left and 1 right left, so I can go either way, either down or right. But if I go down, down, right, down, down, I've used all 4 of my downs, so the last one has to be a right. If I go down, down, right, I've used both my rights, so the last one has to be a down. If I go down, down, right, I've used both my rights, so everything else has to be a down. What if I go down and right? Well, I still have 3 downs and 1 right left, so I can go either way, either down or right. If I go down, right, down, I've still got 2 downs and a right, so I can go either way. If I go down, right, down, down, I've still got 1 right and 1 down, so I can go either way. If I go down, right, down, 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 I've used all 4 of my downs, so I have to go right for the last block. If I go down, right, down, down, right, I've used both my rights, so the last one has to be a down. If I go down, right, I've used both my rights, so the last 2 have to be downs. If I go down, right, I've used both my rights, so the last 3 have to be downs. That's every possibility with just starting off with a down. But if I start off right, again I've got 1 right left and 4 downs left, so I can go either way. If I go right and then down, I've got 1 right left and 3 downs, so I can still go either way. If I go right, down, down, I've still got 1 right and 2 downs, so I can go either way. If I go right, down, 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 I've still got 1 down and 1 right, so I can still go either way. But if I go right, down, 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 I've used all 4 of my downs, so the last one has to be a right. If I go right, down, 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 right, I've used both my rights, so the last one has to be a down. If I go right, down, down, right, I've used both my rights, so the last 2 have to be downs. If I go right, down, right, I've used both my rights, so the last 3 have to be downs. And finally, if I go right, right, I've used both my rights, so the last 4 have to be downs. And that's every single possibility. And if you count them, you'll find out that there are 15. So there are 15 direct routes from D to I. 15 different paths that you could take, all of the shortest possible distance going from D to I. Now the second question is, how many direct routes are there from I to J? Well, again, I to J doesn't involve the entire network, so you can forget about everything except the part between I and J. Now you can see that to get from I to J, you've got to take 2 rights and 2 downs in some order. And you play the same game again, except the tree diagram is going to be much simpler here. In fact, since we went through that long one, I'll leave that to you and just throw up the result. But you can do exactly what we did before, except this one's much easier, and you only get a much smaller tree diagram, and there are 6 of them. So it turns out if you go through that, much simpler than the first one because you only have 2 rights and 2 downs, you'll get 6 different routes from I to J. I just didn't want to go through all that again because I've already done it once, and I think you can follow along. Do that yourself. How many direct routes are there from J to W? It's clear there's only one, because if you look where J is and where W is, there's only one direct way to get there, and that's to go up, 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 up. So that one's pretty easy. Next, how many direct routes are there from W to B? Well, again, that only involves part of the graph, so I just forget about the rest of it for a while. And this time, I will note that you need 3 rights and 2 downs, but I'm going to leave this one completely up to you. I'm even constructing this tree because you need practice with that. But if you do construct the tree for 2 downs and 3 rights, you will end up with 10 different routes from W to B. Take the time yourself to actually do that and make sure you can get 10 routes. In any case, I think you can guess what the final question is going to be. They want to know how many direct routes are there going back to the beginning, they want to know how many direct routes there are from starting at D and ending at B. And what we've done by breaking it down into subtasks is make that answer easy once you've gotten the other parts. So if I want to know if I start at D and end at B, how many direct routes there are, all I have to do is take the number of direct routes from D to I, the number of direct routes from I to J, the number of direct routes from J to W, and the number of direct routes from W to B, and multiply them together. Well, that's nice because that's what I just did. The fundamental counting principle says all I need to do is take those subtask totals and multiply them together. But I already know that it's 15, 6, 1, and 10. So by the fundamental counting principle, there's 15 times 6 times 1 times 10. That'd be 900 direct routes from D to B that pass through J and W. In other words, they want you to go in that order, from D to I, from I to J, from J to W, and W to B. If you do that, there are 900 direct routes.